expectation.
อ่าฮะ
The formula for expectation.
How can we calculate the expectation เอาก็เขาบอก special thing ไง
E of x is the formula for calculating expectation is xi pi. So what is the outcome and the probability?
อืม
อ๋อ
Xi pi. That's how you calculate expectation.
yes
He will not ask continuous random variable. So what he will usually
He only has the discrete.
Yeah,
Discrete.
because I don't think people will be happy trying to solve that integration, the double integration. So he will probably give you like those random variable tables and ask you to calculate e of x, or
โอเค
you may also be asked to calculate a function of a random variable like x squared. So what is e of x squared? Simple, just do, so it's e of x squared. X is literally just summation of x squared pi. So x, so just square the outcomes and then the probabilities.
โอเค
Yeah, that's probably important. Variance, that's also important. You need to know variance. In my cheat sheet, there's most of the formulas for this already, so you don't really need to write it down. The cheat sheet I gave you, that has formulas. You should know also the variance formula by heart. Variance formula.
is the
E of
expectation,
x
right?
minus e of x square, I think. So it's e of x square minus e of x, the whole square.
Do you have to put the probability here
No, because you have to calculate e of x first.
So we have to only remember this formula, not this one. What is it?
no
It depends.
the
If you ask cheat sheet, if you take cheat sheet, no need to remember. But if you don't take cheat sheet, it's better you remember both. Some are easier using this. Some are easier using this. Depends on what information you're given. Another thing you need to know is conditional, like e of
ใช่มันเหมือนกันแต่ว่า
e of x. So where like maybe y equals to 1 or something like that. Conditional expectation and conditional variance. So maybe var x given y equals to 1. There's when you see conditional, you should always just think about it like what is the variance in, if this is the column where y equals to 1, you want to just think what is the variance or expectation of this column, because this is the only column that is occurring. Because and if it was a function of a random variable, so say you have expectation x plus y given y equals to 1. Since it's a conditional and a function, you can just plug it in. So x plus 1 given y equals to 1, and you can simplify. You should know the properties of expectation. So if it is x plus y, you can separate it, e of x plus e of y. You should remember all those properties. And e of some constant times x is literally a times e of x. These very important properties you should remember. And the law of iterated expectations, which is e of y given x is just y. E of y. Is it e of y or yeah, it's e of y. Yeah. Law of iterated expression. You should remember that too. What else? Yeah, that's pretty much that. Law of iterated. Independence. You should know independence. Independence is defined by when the two probabilities, so event A and event B. So the probability of event A and probability of event B. So it's literally the probability of the two outcomes is just the probability of the individual outcomes. And there's mean independence, which is e of x, y given x is a constant. That means what does that mean? That means if you have a population and you segment it by like e of y given x. So here is like x equals to 0, x equals to minus 1, x equals to 1. That means the mean for e of y here is the same as e of y here, which is the same as e of y here. This is what we call mean independence. If it is independent, it will always be mean independent, but never the other way around, as the professor said. There's also uncorrelated, which means the covariance. uncorrelated. Yeah. Covariance between x and y equals to 0. This is uncorrelated. The definition for uncorrelated. So if it is independent, it's mean independent and it's uncorrelated, but it never goes the other way around. This is important because in OLS is one of the only estimators where unbiased is consistent. Because OLS unbiased definition comes from E of u given x equals to 0, and the consistent definition comes from E of ux equals to 0. Hence, in OLS is the only special estimator where unbiased means you're also consistent. That's why this is mean independent and this is uncorrelated. You see? Yeah, that and what else? La di la covariance. What does this say?
Is this all in the chapter 1?
No, I'm jumping chapter 2.
We already chapter 2.
Estimation.
โต้เปิดชี้หรือยัง
Oh, estimation. I mean, he will never ask you to estimate, but you should know the difference between when there is a hat and no hat. This is a parameter which comes from the population, and hat means it's a sample. It comes from the sample, and it's our estimate. You know the difference, right? Parameters are constant. Means like it's something that already exists, and estimators are trying to guess what the parameter is based on your sample. Last property of sample. Yeah, he's not gonna cover the.
ส่งไปให้ใครอ่ะ
He asked about the theory.
ส่งให้ตัวเอง
ส่งให้ในกลุ่ม
ให้รุ่นน้อง
It's too statistical. He might not
ถ้า
be
พี่ตาม
covering
ทำเรียนที่นี่ตอนสองเรียนจะเจอเขาก็ได้เดี๋ยวเขาก็
sampling
จะมาสอน
distribution. Yeah. Yeah, I don't think
เรียนไม่จบสองปีนะ
he didn't even talk about this with you, right? I know he didn't. He just skips the central limit theorem. So let me go to the next slide.
Did he talk about it in class?
no
So
Not that I
introduction.
recall. I think no.
No, right? Yeah, he didn't with us either. So what is OLS? So OLS is OLS.
Where is this the estimator, right?
It's an estimator, ordinary least square. What it tries to does is it tries to decrease all the the residual. This is what we term a residual. So the one between the real observed output and the lie output. This is the residual you had. And the OLS try to decrease the square areas. So it tries to make it small. So it tries to fit the line by decreasing residual. That's the point of OLS. How do I? Let me just see where it tells you that. Yeah. Okay. I'll tell you. So he talked about 3 interpretations of the OLS. 3 interpretations of the OLS. One is E of y given x, linear expected. I forgot what is the best linear conditional expectation. Linear conditional expectation. So this is your first interpretation of OLS. What this means is the line, the regressing line, is always the mean at every point. So at x equals to 1, it is the mean. So z is at the middle, and at x equals to 2 is at the middle. So yeah. So in this situation, you always have, these are the 2 conditions you always have. U given x equals to 0. So that E of ux equals to 0. This is unbiased. BIAS, biased and consistent. So under the first interpretation, it's always unbiased and consistent. You should, by the way, memorize the definition. So unbiased is given by this condition, and consistent is given by this condition.
ซึ่งนี้ u of
E of ux, and this is E of u given x
Equal to u.
No, sorry, 0.
คือ
Ugly handwriting, right?
so it means that no error so it's
Yeah, under the first interpretation is always unbiased, consistent.
What slide you are at now?
Lecture 2, yeah, slide 5, I think. Slide 5, lecture 2. Then you have the second interpretation, which is the best linear approximation. What this just means is, well, in the first interpretation, we assume that e of y given x is linear, but maybe it's not linear. It's something like this. So you're approximating its linearity. That's literally it. And the only thing you need to know is it's consistent but not unbiased. E of 2x equals to 0. It's always consistent under the second interpretation. The third interpretation is causality.
This is consistent or
Consistent, yeah. E of u given x is consistent.
but
It's
not
the,
unbiased.
yeah, it doesn't ensure unbiasedness. Second interpretation doesn't give you unbiasedness, but it gives you consistency. The third interpretation is causality. So causality means that x literally causes y, and that gives you neither no consistent and no unbiased. You have to use some theories. You use theories to justify these two. That he will probably teach you in the later lectures. You need to know the relationship between x and y. Like, so if it is like log, log x y or x y or x log y and log y log x. Sorry, I'm writing it backwards. I'm so sorry. Log y, there you go. So here, this is just like change in x equals to beta 1, change in, I'm writing it backwards again. And here is, yeah, you can just look it up in the notes I give you, but you should know how to do this interpretation when it is different. Like, and then, let me just go through, see if I missed anything. Causal model.
สรุปชัด
อะไรนะ
Solving for parameters.
สมองแต่คีย์
Why do we have to know about the T interpretation of the virus? Like
What?
what important about the T
คือ
interpretation?
มีที่สอนนะ
Causation. This allows you to say that x causes y, but the first two interpretation, x and y happens together. It occurs together. Means x may or may not cause y. We're not really sure, but we know that when we see x, we see y. But here we know x directly causes y. It's like, when you see a dog and a cat on the street, like just because you see a cat when you see a dog, like that. Like in causality interpretation, like yes, when I see a cat, I will definitely see a dog. But the first two means that I see a cat and a dog together sometimes.
They don't cause each
Yeah, they
other,
don't cause
right?
each other.
จำไว้ว่าเป็นหมากับแมวเจอหมาเจอแมวไม่จำเป็นหมาต้องมีติดแมว
ๆก็ชิว
Dummy is something where the value is 0 or 1. So the dummy trap is basically when you add all of the population into, so say you have like 4 quarters, Q1, Q2, Q3, and Q4, and then when you write your regression equation, you add all 4 plus a constant.
เร็วมาก
Then you have the dummy trap. This is what they call multicollinearity, because one of the betas can be expressed as a linear function of the other betas. This means your betas are not unique, like because OLS solves a system of linear equations, like it tries to solve a I don't know if you have taken linear algebra, but when you have like 2 equations, a third equation, a function of the first 2, you cannot solve the system anymore. That's the yeah, but you don't need to know that. But this is what they call multicollinearity. A dummy trap is basically a specific version of it, like a specific example of multicollinearity. What else? Oh, you should probably know that. That's very important. You should remember that. How do you beta 1? Beta 1 is the covariance between x, y, and the variance of x. This you should know. Variance of x.
What slide you are at? You are in chapter 3, chapter 2. Chapter 2.
chapter 2
page 20 free
20
It's important you remember this. Beta 1 is technically the covariance between x, y, and over variance of x.
What
ที่เอ็นเขาให้ช่วยออกข้อสอบด้วยปะเนี่ย
what will you use this
ให้ตรวจ
for?
this maybe
ปกติ TA ตรวจ
I don't know, maybe if he asks you to calculate or something, but you should. It's like to calculate your beta 1, but you can only use
covariance covariance
covariance of xy over variance of x. I think the formula for covariance is expectation of I can't remember it by heart. E of x minus e of x
มันน่าจะ
times y minus e of y. This is the I think this is the formula for covariance. I think. Wait.
so he will keep the equation and we have to use it
Probably.
to solve some parameter or some factor that they don't give us in the
He just tell you to memorize, but I don't know how to. When he did it last semester, I don't know. But it's something that you should just know that beta 1 is calculated using covariance xy over
Okay.
variance x.
okay
And that's pretty much lecture 2. Consistent, yeah, you should know consistent and unbiased. Unbiased when e of x u given x equals to 0. Consistent when e of x u equals to 0. That two conditions.
write
so it
write
is
down
just in
E of u given x equals to 0 and e of
what does it mean by this condition
this is unbiased. If you have this condition, you are unbiased, and if you have the bottom condition, you are consistent. OLS is consistent. Unbiased means on average, OLS will get your estimates correct, and consistent means when you use have large sample property, it will be accurate.
when large number is mean that error is equal to 0
No, that's not what it means.
then what does it mean
ใกล้
here
ใกล้กว่าใกล้
This means the first one means that the error term is uncorrelated to any of the regressors. I don't know if we talked about the omitted variable problem. Probably not. It's like you'll learn why this is the case on lecture 6. This is on lecture 16. But for now, you just need to know the top is unbiased and the bottom face is consistent. He'll tell you why the top is unbiased in lecture 6. The omitted variable one is consistent. Consistent and unbiased.
if large if in large y existed
No, it's not. It has nothing to do with it. It just says that if you have this condition, that means OLS will be consistent, and
Wait.
which means it will be
what this condition mean it is expected of x
expectation of error term u and the regressor x. And this is expectation of error term given regressor x.
so it means that the error term multiplied by x equal to 0
Yes, on average, e of u given x. Error term. On average, the error term multiplied by x equals to 0. He will not ask you to prove it. You don't need to know too much in detail. You just need to know that this means consistent and the top one
I
means
just
unbiased.
want try to understand what does it mean by consistent because now I get the formula right but
Remember
not sure
when
how.
he did the p-lim calculation for you, and then the distribution is like, as the. Let me just go to that lecture again, since you are asking out.
sorry
No
โค้ชจะเอา
worries.
เตรียมใช่ไหมตรงมือของมันเนี่ย
no I have to go a little slower because I learn
โค้ชอยู่
here.
always learn at home
Here you go. Remember?
This
This one.
remember นะ
If your estimator is not consistent, that means you will need a really large sample to be correct. But if your estimator is consistent, it will converge faster.
it's convert faster so
Yeah,
this means
okay.
that it is convert fast
Converge faster, yeah. Like it will arrive at the correct value faster based on the number of, like, just by a little observation, it will arrive at the correct value faster. That's what consistent.
okay thank you for your explanation
No worries.
that's pretty clear
อะไรคือ reverse pattern
convert to the true value first แบบ true parameter อะไรอย่างเงี้ยหมายถึงเขาบอกว่า e expected e u คูณ x อะถ้าสมมติว่ามันมีมันแปลว่ามันจะสามารถ convert to true parameter ได้ close to true parameter แต่ไม่รู้นะว่าทำไมมันอาจจะหมายถึงว่า error ไม่ค่อยมี
Okay,
ใกล้กัน
lecture
มันใกล้กัน
3.
ขึ้นใช่ป่ะมันไม่กระจายทำให้แบบไม่ต้องใช้เอ็นเยอะในการที่จะแบบเข้าใกล้กัน
มันไม่ค่อยเข้าใจสูตรหรอกนะว่า
I mean, you can ask anything since we are finished lecture 2. What do you, anything you want to ask?
มันคืออ่ะ
Okay, จบสองแล้ว
โคตรไหว
so I think we are still questionable about the formula
ไม่
here
เป็นไรเขาไม่ออกสอบหรอกโต้ผู้สอบไม่เหมือนตอนนั้นปิดเทอรี่
why this course is to be consistent
Why?
Yeah.
Because when you do the estimation, this is like you don't need to know it, but since you're asking, I'll explain it to you. OLS uses moment conditions to calculate conditions. So you have E of xu, and then you start by calculating this. So y equals to beta 0 plus beta 1x plus u, right? And you rearrange y equals y minus beta 0 minus beta 1x equals to u. You replace u, e of x, y minus beta 0 minus beta 1x equals to 0, and this is how OLS starts its calculation to estimate your parameter. So if this condition fail, then your OLS also fail.
okay so it's a formula here they try to prove right
Yeah, the proof exists. Like it uses these two conditions. It uses these two conditions to get your beta 1 and beta 0. So if you don't have these two conditions, your OLS not correct.
okay
Do you want to ask like example in the class? It will be how similar it will be to the exam because
Example in the class.
yeah
The exam probably harder, much harder, because it involves multiple steps. So it will probably be like, transform model. After transform, it will interpret this model, and then if the p-value, and then should you reject, do a hypothesis on the model. It's like multiple steps.
okay
So you probably yeah. Anything else, or should I go to lecture 3?
any question you
ทำไมมันถึงอยู่ดีกลายเป็นเครื่องหมายเท่ากับยู
เขากลับข้างเขากลับข้าง
so much do you have line ID she
อ๋อ
asked
มันก็ต้องเป็น
for your line ID
B
Yeah, I have
คือ
อันนี้ลบ y ลบ b ศูนย์
ลบ
no we can be friends together
อันนี้มันแทนยังไงนะ แต่ว่า
เมื่อกี้เขาบอกว่าถ้าสมมติว่ามัน
เขาบอกว่าเขารีบ
at midnight and
แท
she
น
will
ค่า
have
อยู่
a lot of
ใช่ป่ะ
question at midnight then she send me and I cannot answer her
If you send me at night, I won't reply
ก็
because
คืออัน
I
นี้
sleep.
ก็คือพจน์นี้แล้วก็อันนี้
พลอยพลอยพลอย
แล้วก็
เขาก็สอนเขาพูดอะไรนะ เอามาแทนค่าแล้วไหม
ฮะ
You don't need to know how to do this. This is because he asked. This is you don't need to know how to
เอ
do
อ
this.
อันนี้คือมันเป็น
ผ่าน
สู
ไอ
ต
วอ
ร
นทู
this is how it come to condition
Yeah.
of consistent
โอ้ you can speak Thai
เอ
I
อ
understand you
คือถ้าเกิดมันไม่มี condition เนี้ยเขาบอกถ้ามันไม่มี condition เนี้ยมันก็จะพูดไม่ได้ว่ามันจะเป็นแบบนี้
ก็คือจะไม่แค่นี้
จริงๆเขาสรุปแหละแต่จริงๆถ้าตอนที่อาจารย์พิสูจน์อะมันมียาวกว่านี้อันนี้สรุป
Okay.
โอเค thank you very much anyone want to add line
แคทแอด
อ้าว
what?
หรือว่าให้เราลากเขาเข้ากลุ่มไปเลยไหม
ไอแค
ทุ
ท
กคน
แอด
ก็
นะ
จะ
I can send his
one his life
his contact
Okay.
แต่
Now
ว่า
I
เรียน
can
รู้เรื่อง
try
ใช่
to.
ปะเรียนรู้เรื่องใช่
ไม่
ปะ
ค่อยมัน
แต่
ตาม
ว่า
ไม่ทัน
เห็นออกไปตอบสไลด์ได้หมดแล้วก็
เราทำผิด ที่ออกไปทำผิด ถูกครึ่งเดียว
น่าจะอยู่ตามที่ไปเพราะว่าที่เขาบอกเฉลยมาแล้วคือ
คือที่พี่ออกเพราะว่า
หมายถึงอะไรนะ
ก็บอกว่าทำผิดอยู่
อ๋อ
เลยแบบยังไม่ออก
แต่รีบๆไล่เขาไปเชปเตอร์หน้าได้เราจะได้ไป
let's go let's go
Let's go speed run.
yes
Speed run. Lecture 3 is nothing new. It's just like now. Lecture 2 is just like one regressor, but now it's just more than one
Okay.
regressor. But still 3 interpretations saying linear conditional expectation, approximation to linear conditional and causality. Same thing.
โอเค easy then
Yeah.
I think
Just with more estimators. Same thing still.
did you mention the goodness of fit as well
Yeah, it's at the end.
is it in the chapter T or
Yeah, it's in chapter 3.
okay let's go
So it talks about multicollinearity. I guess I talked about that a little bit. So multicollinearity is multicollinearity is when you can write one regressor as a one regressor. When I'm not gonna write it out. I'm not gonna write it too much. It's like when you can write one regressor as a linear function of another, like maybe beta 1 equals to beta 2 plus 2 beta 3. But when you have this like that, when you can write one regressor as a linear function of another, then you have multicollinearity because OLS estimates using the the matrix calculation. So the matrix becomes unsolvable if you have this condition. Yeah. That's why you cannot have this condition, this multicollinearity problem.
Do we have to solve the matrix in the midterm exam?
No, you don't have to.
Oh, okay. Then let's go.
He doesn't expect you to do the differentiation of matrix. No, I don't tell Professor to do the exam. He does it by himself. So non-linearity and linear regression. So interaction terms. So I'll talk a little about that because remember when the professor gave you the equation, the wage equals to beta 0 plus beta 1.
I hate this equation.
What was it? Eduku plus beta 2 grad
To get something
plus beta 3
female,
male
female,
plus beta 4.
male, female.
No, it's eduku. Male, yeah, edugrad. Edugrad plus beta 5 edumale
โอ้เป็นภาษาอังกฤษหรือ
plus
เปล่า
beta 6 male edugrad. Yeah. So he'll probably ask you what's the impact of wage on education.
What is mean in this term?
What is education times edugrad, edumale,
It means that education and
graduate.
have
Yeah, multiply. This is a random variable and this is a random variable. You're just multiplying two random variables. Remember like x, y, or x1 and x2. These are just random variables. But what he'll ask you is like, what's the impact of education on wage? First step, always just remember calculus, right? You just differentiate it with eduku.
Yes.
So yeah, since beta 0 is a constant, gone. This has eduku, so you have beta 1. This has nothing to do with that, so gone. Nothing to do with that, so gone. But you have this is eduku, so it's beta 4 grad. And this has eduku, so it's beta 5 male. And this has eduku, so it will be beta 6 male grad. And the best thing to do is to draw that.
Like he teach
Yeah.
today.
So male, female, and then you will have grad, no grad. So you just plug it in. Male is so 1 and female is 0. Grad, no grad. So grad is 1, no grad is 0. You just plug it in. So in female, no grad. So since no grad is 0, so you plug in 0. So beta 4 is not there. Female, you plug in 0 here. Beta 5 is not there. And you plug 0 times 0 is still 0. So here is beta 1 only. And then you do this quadrant. So female 0, grad 1. So you plug in grad for 1. So you have beta 1 plus beta 4. And you female 0, so beta 5 is gone, and 0 times anything is 0, so this is also gone. And you do the same, male, non-grad, so this is beta 1, so since it's non-grad, beta 4 doesn't go. See, 0, so it's gone. Male is 1, so you have beta 5. But this is non-grad and male, so that's it. And for this, it will be beta 1, so grad is 1, so you have beta 4. Male is 1, so you have beta 5. And male and grad 1 times 1, so then you will have beta 6 here. And that's how you do this thing. And then he'll ask you probably like, if is there any difference. So he can ask you like, within college graduated, what is the difference between male and female? So you just look at these, you just compare these, you hypothesis test these two. Or if he asks you this group and this group, you hypothesis test these two.
This is multi-variate linear regression model, right?
Yeah, that's how you interpret.
What number is it?
4, beta 4. Sorry, I handwriting.
So we have to do this calculation.
Yeah, you do the differentiation first, then you try plugging it in.
We like this when we have a two factor like education
Yeah, yeah.
and also have
No.
female and male.
Yeah, because you have 2 dummies. So 2 dummies means like each dummy is 0, 1. So you have 4 possible outcomes.
So we
Yeah,
have to
that's why
like
you
this.
split it in 4.
But if we don't have 4 possible outcomes,
You can
we
just
don't
split
need-
it 2. You just split it into 2.
Oh.
Or you can split it into like maybe if he. I don't think he'll give you 6, but just say.
What should they do again after we completely do this?
Oh, so it just depends on the question. So if he asks like, like for people who graduated, so you
Okay,
just
so
look
just
at this.
decide.
What's the is the wage for female and male the same? So it will be this.
Oh.
Or if he asks like, for female who graduated, do they have the same wage as male who don't graduated? So you compare these. You hypothesize test these two.
Another for
Or
them.
these two.
When
or
we find
you-
the difference, we use this minus this.
It depends on the question. Like.
If ask male more than female, we use this minus this.
More than
Male more than female.
Since you have 4, he'll ask for grad. He'll probably have to segment it. Like so, for non-grad, is male higher than female? So you use the non-grad.
For
Or
them.
if for grad, is male higher than female? Or within male, is grad higher than non-grad? Like that.
clear.
Okay. What else?
This is chapter 3, right?
Yeah, we're still in chapter 3.
ฉันเพิ่งเรียนวันนี้เลย chapter 4ไม่ใช่เหรอ
Alright, let's do the equal FOC, bias, consistent, blah blah blah. Oh, goodness of it, SER.
What important about
can you back
Yeah.
no next slide
Wait.
no
No.
you look at your screen
Next slide. This one.
next on the process
This.
can you summarize the process again
Which process?
yes
Which one?
หมดแล้ว
It's already gone.
I see it with next
What slide พี่บัง
จำไม่ได้เดี๋ยว next อันนี้
Oh,
can you summarize it
yes. Okay. Model construction. Functional form, non-linear integration, control.
นี่คือเดี๋ยวจะอ่านหนังสือต่อ
This is how you do special project.
Yeah, this is how you do special project or thesis. So you start with your research question. Like you interested in
Wait, do we have to do this in midterm Excel?
No. Maybe.
It's like real world process.
Yeah.
Oh, this is how.
Yeah, you should understand those all over. Like maybe you're interested in studying wearing black color,
ไม่รถ
wearing
ข้างห
black
น้า
shirt
จอดขวางไว้
at night and car accidents. Car
Really?
accidents.
This is really
That's
related to
it
each
comes
other.
to the research question.
Okay, this is research question.
So now you all.
ไม่น่า
โอนไปไหน
ขอไม่
Yeah, so your explanatory variable is y and x, and then you start your model construction. So y, car accidents, but also x is like wear black shirt.
Wear black shirt.
And this is car accident. But then you also have other things like maybe
Author.
other things that affect, maybe they are drunk
Weather.
people at night.
Weather.
Or weather.
Okay.
Weather. So you have like another x2, and then you have like maybe
Okay, just
drunk people.
Okay.
ขอ
just
Something
be
like that.
parameter.
And then this is how you do the model. The first, so he asked you to say whether if you want the first, whether your research is the correlation research or the causation research.
สรุปคือเราสอบ4 อัน
you
แค่ที่3
so
แล้ว
interpretation 1 and 2 is correlation, and interpretation 3 is causation. So this is how you do your research. Under causation, if you do correlation research, you are always unbiased, and under 1 is always unbiased and consistent. But if you do causation, you probably have to use some theories to justify the E of your given X. Like you have to justify that, this is everything that causes car accident. there's nothing else. So we don't have any like confounding variables that are outside the model that may affect y.
So your theory, you have to prove that your estimate is consistent and unbiased. as well.
Yeah. When you use number 3, but under 1 and 2 is always under 1 is unbiased and consistent. Under 2 is always consistent.
And then you have to put all factor that affect y input. So
You should, controls. That's why whenever somebody writes equation, they write y equals to beta 0 plus beta 1, whatever they are interested in, plus control. This control is the thing that they are trying to. The control, ensures your model is good, is unbiased and consistent. That's why they write. When professor write an equation, he keep writing control.
Okay, let's see. Is that all about this slide or?
So you should check for multicollinearity. You should make sure that you cannot write one of these as another. There's more, like on the lecture 5, he will talk about the scarcity thing. That's also important, but for now, I think no multicollinearity, control variables, that's enough. Yeah.
อันนี้เขาเขียนว่าอะไรนะ correlation
or causation research.
causation
Yeah, is your equation supposed to be interpreted as correlation? Like, just because I see a cat, I will see a dog, or seeing a cat causes
Will
me
make
to see
you-
a dog.
Okay, that's causation.
Yeah. Under interpretation 1, 2 is correlation. Interpretation 3 is causation.
correlation
And 1 always gives you the consistent, unbiased. 2 is always consistent, and 3 you have to use theories to justify consistent and unbiased.
Okay, let's go.
Let's go.
วันนี้อยากจะได้สไลด์4แล้วก็เรียนไปเลย
R square and adjusted R square. So there are 3 measures of goodness of fit. So what the goodness of fit tells is
R square.
How well your x explains y. How well. So when they say like R square is equal to 0.7, that means 70. You can interpret as 70% of y is explained by x. That's what it's
อา
trying
จา
to
รย์ทด
say.
สอบตรงนี้ไหม
Okay.
อ่า
Okay, will be your answer.
Which means if the if R square is high,
High is
very
good.
right? High is very good.
Yeah, it's interpreted to be good. High is good.
Okay.
Is explained by
Explained by x, yeah. Okay, this is how you can see what R square means. So there are 3 different measures of goodness of fit: SCR, R
Okay.
square, and adjusted R square. R square is always between 0 and 1, but adjusted R square can be negative. This is because adjusted R square penalizes you for everything you add. So you cannot add like everything in the world, like y, x1, x2, x3, x4, because in theory, the more x you add, R square will always improve. So adjusted R square punishes you for adding one more variable. So you can become negative here. So you should know that adjusted R square can be negative.
Is it not good or is too complicated to use the R square?
Actually, adjusted R square is better to use in practice because, or you can just keep adding more variables to your regression, and or R square will go up. But it means useless. It's useless because you cannot interpret the results anymore.
If your model are well constructed, then R square adjusted is good, right?
Yeah, it shouldn't be negative. If your adjusted R square is negative, that means your model
Maybe-
really bad, really bad.
Add noise.
It's adjusted R square. Adjusted R square has the bar on top.
So
That's
what
adjusted.
which one is better between R square and adjusted R square?
He won't ask you that, but people usually use adjusted R square because it penalizes you for adding every.
อะไรนะ
อาจารย์ให้ใช้ adjusted R square.
You should adjust properly, right?
Yeah.
Shouldn't be
And
negative.
what about
SER.
SER?
The standard errors of regression. Let me read on that. We don't really use that. Goodness of fit tells
ใช้
where
adjust
how and
ที่เขาใช้ในโปรเจกต์จริงๆอ่ะ
อ่า
แต่เขาบอกว่าแบบจริงๆมันadjusted R square สามารถเป็นลบได้ถ้าสมมติว่าเราไปแอดอะไรที่ทำให้แบบมันไม่เกี่ยว
งั้นเรา
งั้นอาจารย์นะ
divided
Adjust ไว้ก่อน
by I. This is one of the mean you measure the goodness
they
of
will-
your
Yeah,
model,
this is
right?
one of the
What will
goodness
ask?
of it, but no one uses SCR, and he will not ask.
อาจารย์
I don't think he'll
วัด
ask
วิว
you
อาจารย์นะ
SCR.
Will he ask us to do some calculation about the goodness of it?
Yes, you should know that the R square equation is explain sum of square over total sum of square, which is equal to 1 minus residual sum of square over total sum of square.
What the heck โอเค
What good it is? ESS and TSS
สไลด์21
explain
slide
sum
21.
of square. What does it mean by ESS and TSS?
Explain sum of square means that, I say that regression is basically trying to smaller the squares, the sum of squares. That means the number of explained sum of squares and the total sum of squares. So say this one and this one and this one is explained. So it's like maybe this is explained and this is the total sum of squares. This is our R square equation.
This is like ESS and total is TSS.
Yeah.
It's like ESA is like subset of
Yeah.
total
Yeah.
So explain about
It explains about how well your X explain Y.
okay so if it explain well should not be big
Yeah, if it explain well, that's why your R square will go up because if it explain well, your ESS will go up.
No, I mean-
small.
Oh yeah, it will be smaller. Yeah, it will become smaller and smaller.
to be
and
yes
then, yeah.
okay
Okay.
So,
So-
this you should just
I noted that we don't have to remember the formula, right? For the R square. We don't have to remember
Yeah,
this.
the-
I noted.
we don't have to.
Yeah.
Not the complicated one. Maybe the simpler one.
Oh, really? Then they will give us ESS and TSS, right? They will give this.
Yeah, maybe
Maybe.
I'm just covering it just in case he.
Oh, okay.
Yeah.
Experience.
So the higher is the better.
R square higher is the better.
So if ESS is
Higher.
higher,
That means R square will be higher.
Mhm.
This
เพราะเป็
means
นตัว
the
ส่วน
sum of
เอ้ย
squares
เป็นตัว
which are
เศษ
explained is explained by your X.
so if we have a lot of this,
No, don't think about this like this. This I'm just drawing so you can see. But it's
as square means there are a lot of explain
yeah, it's more is explained than yeah.
if you flip the equation, there will be the residual
Because
residual sum.
X
What does it mean?
ESS plus RSS equals to TSS.
Oh.
Because explain and the not explain is the total that exists.
Okay.
got
This
you
is the explained sum, residual means
Okay.
not explained sum, and this is the
So
total
this is
sum.
just a fifth of equation, right?
Yeah,
I see.
this is how the R square comes from.
But it is the same meaning. The higher is the better.
Yeah, yeah.
Okay.
That's why you can rewrite it like
Oh.
this. You can just
Oh,
rewrite it like this 'cause
explain.
you just
Okay.
unexplained
We also have to remember the equation of R square. Just
nah, you don't need to know that.
Very
Too hard, anyways.
Oh.
But adjusted R square can be negative, so that's important to know because it penalizes you by subtracting.
Okay, I know now. Because you very highlight it. You spread it out. Okay.
What else do I need to
this
cover?
for our
Okay.
square.
Yeah, this is R square. Adjusted. No,
where is the penalized term again
the penalized term is this. You see, it's penalizing you every k you add. It decreases your R square.
What is K?
Number of regressors. So when you add more k, you get punished. Your R square go down.
Okay, I see.
requesters
why when we increase the value the R square will go down
What?
why when we add more k
ตัวส่วนมันเยอะขึ้น
เพราะว่าเอา n ไปลบสมมติอันนี้5อันนี้5มันก็จะเป็น
แล้วส่วนมันเยอะ
มันก็จะเป็นอันนี้ข้างบนมันจะเพิ่ม
What is what difference between N and K?
เป็นลบ
N is
Number of observations.
N is observation.
K is the number of regressors.
So for us R square the higher is better or
R square is higher is better. Adjusted R square higher better.
Observation.
It's the same thing, but adjusted R square can be negative, and R square is only between 0 and 1.
so higher is better.
Regressor. Okay. Got it now.
One thing you need to know about that.
K increase the value of parenthesis go up while RSS decline. K this is in negative term.
So basically if the number of Ligaser is higher than your observation it will become negative
มันจะ
Negative and then positive อ่ะ
but how
Okay.
when it is
You want me to explain in detail? Let me just read it then. But the idea is it can be negative. Yeah, I mean it says so at the bottom. Adjusted R square is less than or equal to 1. Just yeah, you don't need to know why though.
Okay.
The proof, you can prove it yourself when you're free. I'm not gonna do the proof.
โอเค
Okay let's go
มันน่าจะ negative จากตรงนี้ป่ะไอ้อันนี้มันไม่น่าจะเกิน n ได้ป่ะเพราะ observe 10 แล้วมันตัวเบต้า
If it is negative, then your model is very, very bad.
1 observe มีหลาย Ligaser หรือ
It
เปล่า
shouldn't be. Yeah.
Normally should be positive.
ใช่ไหม
โอเค let's go ไหม
Yeah go
โกแบ็คเอ้ยไม่ใช่
เอาเล่นมูฟ
ไม่ได้เล่นหมู
next
go next not go back
One
go
thing I
next
want to say is that this is very important one.
very important
But no,
Important.
it's because the
Every point.
terminology in your lecture note they write n minus k minus 1, right? Degree of
Ligaser.
freedom.
Ligaser
One beta 2 x2 plus da 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 plus beta k x k, right? In your lecture note it says
จำนวนตัวที่
df
เพิ่ม
equals to n minus k minus 1.
จำนวนพจน์
It's the same as when the professor write n minus number of betas. It's the same thing because when the regression counts like 0, so k that means 1. You get that?
no I don't get it
In your lecture note, it's the degree of freedom is n minus k minus 1. But when the professor say it's just n minus the number of betas. So beta is 1, 2, 3.
Include beta 0 and
Yeah, because here at
minus
beta
1.
k, here you this start from beta 0. So it's not this is not counted technically. That's why you have the minus 1. So it's the same thing as the number of beta. So you count k plus 1 is the number of betas.
how I can find n is 1
Yeah, n is observations.
N is
It's the
observation
observations.
K plus 1 is the beta number of
Minus 1
beta
is the
K minus
1 is the number of beta. Yeah.
so this is not an observation
No, observation they give you on the OLS, the output method.
Okay.
Let me just go to chapter.
do you like some cake
No.
oh if you want to go it out of my I want to watch it
What?
in
N minus.
we almost finished now
Almost finished.
ทำไมเราถึงไม่นำเราถึงไม่นำ
Almost finished.
เป็นอันเขาพูดว่าอาจารย์พูดว่า K
Very fast. I go very
ก็คือจ
fast.
ริงๆที่เขาพูดอะ K ลบ1
oh again
แต่
โอเค
จริงๆคือจะใช้แค่ Ligaser
All observe
แต่ว่า
is
K
the
ถ้า
number
นับ
of
เบต้ามันจะเป็น
observations.
เบต้าด้วยอันเนี้ยก็คือ
So
มัน
when
cancel
in the
out
exam,
beta
you probably give you like a
แล้วสุดท้ายก็จะเป็นแค่ Ligaser จริง
N คือ observe
observation
CD is the output number of observations. 5 to 6.
is like the sample
Sample size.
เราเอาไปใช้
Sample size.
เราเอาไปใช้ทำอะไร
and
หมายถึง
when
ว่าไอ้
the
degree of
sample
freedom
size we try to we try to find the
ๆ ใช่ตอนที่ถึง F stand
The sample size restrains your distribution. You understand?
I mean that we gather the sample and then
Yeah, you get, when in the real life, you gather the sample.
สรุป
you
คือ
run
K
the
นับ
experiment.
เบต้าศูนย์ด้วยใช่ไหม
K
นับเบต้า
ครับ
0ใช่
แล้วก็ตัดออก
แต่สุดท้ายก็ลบ1ออกแบบนี้
when we train
What?
when
ทำไม
Say it
วะ
แล้ว
again.
ทำไมตรงนี้เป็น K วะ สมมติว่า K นี้เป็น 10 นะ แสดงว่าถ้าร่วมเบต้าศูนย์มันจะมี 11 ตัว
แล้วก็ลบแล้วเหลือ
เหลือ
10คือแปลว่านั่นก็คือเลข K แหละป่ะ
Up to you.
เพราะ K มันรับ
Up to
รับ
you.
จาก
I
ไหน
mean, he's not gonna ask that. I don't know. You can do it however you want.
he got question
สมมติว่าถ้าเราเอาแซมเปิลแล้วเราจะหาเบต้า1เบต้า2เราเอาแซมเปิลมาก่อน
อันนี้เราต้อง develop เองอันเนี้ยคือเราต้อง develop ทฤษฎีเอง
คือหมายถึงเราก็มั่วมาเองได้เลยว่าเบต้าถึง5เบต้า6 2
ใช่อันนี้
โดยที่ยังไม่ได้แซมเปิลว่ามันมี relationship
ใช่คือ final model อันนั้นที่เราต้อง develop นะถ้าเกิดว่าเราทำเองเราต้องคิด เพราะว่าอันเนี้ยมันเป็นความสัมพันธ์ตามทฤษฎีไง ที่เราพยายามจะหาคำตอบ
แปลว่าตอนแรกเราทำโมเดลนี้ขึ้นมาโดยเรามั่วตัวแปรเข้าไป
ใช่เรา
แล้ว
เรา
ก็
กำ
ไป
หนดตัวแปรไงว่าเราจะดูตัวอะไรบ้าง
แล้วเราก็ไปดูแซมเปิลแล้วก็รีเจ็คว่ามันใช้ได้หรือไม่ได้ถูกปะ
ถ้าแซมเปิลก็คือเราเลือกทีหลังว่าแบบมันโมเดลของเราอ่ะมันเป็นแบบเป็นไปตามที่แบบเราคาดการณ์ไหมครับ
แสดงว่าเนี้ยต้องมั่วขึ้นมาก่อน
เราดีเวลลอปเอง
แต่ตอนแรกก็งงว่าเราไปเข้ารีเกชันแล้วก็หาเบต้าก็เลยงงว่าเลยต้องมีแบบ
เราต้อง
Two question. So it's actually start from beta zero,
Yeah.
but then we just 1, 2, 3, and then k.
Yeah.
I think so. Like why do we need to k because k didn't start from zero.
it one
K.
two three four K it K
K
number
is only this, so you still have beta 0 to count for, so you have minus 1. You minus K, which is this many beta.
Oh, minus k.
This is minus 1.
Oh, okay.
Do you get it? Which is same as the sort n minus number of betas.
so it means that we don't include
No, that's not what I mean. It just means it's the same thing but written different ways. Because your lecture note writes like this, but this is how the professor talked about it in class.
And observation log k.
Yeah, K, because there are K here and you have to minus 1 because K counts only for the first beta, so you still have beta 0 to count for.
มันก็คือจริงๆมันก็คือไม่รวมเบต้าศูนย์ว่ามันถึงต้องมาลบออกปะ
yes not include
Not include
beta
it.
zero.
so this if you mean that we don't need to include the beta zero because that
No, it's just it only comes out because when you write your regression equation, you always start with beta 0. You cannot write beta 1 plus beta 2x1. No one writes like this.
degree of freedom
Degree of freedom, this is the equation, but it's the same, is what I'm saying.
It's the same K with this K and this K.
Yeah, it's the same. But if it's the same, that means beta 0 is not counted right now. That's why you minus 1. That's why it's the same thing as here.
If we if this beta K is beta 10,
Yeah.
we will have 0 to 11, to 10.
10.
That have
That means
11,
that's 11 betas.
11
Yeah.
and we minus 1.
Yeah.
to have a
No, yeah. If you have a K is 11, that means you have, if K is 10, that means you have 11 betas. So it's like n minus 10 minus 1. It's the same thing as n minus 11. You get it?
รอบหนึ่งนะก็งงและยังไง
So that means we need to count beta 0 to
Yeah, you have to
Ah.
count beta 0, but in your lecture note is write n minus k minus 1, and I just want to say that it's minus 1 occurs because k does not count beta 0, so you minus 1 to count beta 0 too.
This equation is n minus
K minus 1.
minus 1 not n minus เขาเรียกว่าอะไรวงเล็บอ่ะ
Huh?
พาราเทฟิก
Bracket.
I mean, you can write it in brackets, k plus 1. It's the same
okay.
thing. You distribute it in
Okay,
same
yeah.
thing.
Got it now. Another question, and
Okay.
then what do we do with degree of freedom?
Degree of freedom is important because it governs your distribution. Like your T, like as your degree of freedom increases your, maybe this is like df, and then it affects your p-values. That's why you have to care about your df. Because like maybe like if it's like this, then your p-value may be more, and then here maybe not so much. And it's dependent on your observations minus your
You
beta.
mean if it high, the p value will be high, or it's indifferent?
No, it's just trying to adjust so that you have the correct p-value. It's adjusting based on the observations you have. This has something to do with statistics like law of large numbers and sampling. Yeah.
ไม่ได้เกี่ยวข้องกันใช่ไหม
Okay,
Okay.
let's pass this matter.
And and then just wanna ensure that everything we do here, just wanna recheck the logistic of how to solve the problem.
How to solve the problem.
Yeah. But like the steps as well.
Oh. I'm trying to think of a question to solve the problem.
พี่ปางสรุป เราเล่น
Maybe. So say maybe he'll give you
นี่
like
จับ
an
แบงค์เลยนะ
F
เนี่ยแบงค์เลยเนี่ย
output. df 1 comma
ตอนเรื่องอ่านหนังสือยัง
30
เริ่มแล้วไม่
is
จะไม่ทัน
equal to like 4.11. Then he'll ask you to do the t. So you will calculate the t. If you remember, the square of the t is equal to the square. Sorry, f. I'm supposed to write f 1 comma n, which means this is technically square root of 4.11 is this should give you t 30.
What slide we are in now
I'm just giving a hypothetical question and an example.
อ๋อโอเค
So this is something, and then so you get this. So plus or minus. Oh, you know what? I'll just use 4 because it makes my life easier. Which is plus or minus 2. Okay, then he tells you that you have to know it's positive or negative, right? That you can just do by checking this equation, beta hat minus beta over SE beta. SE is always positive, so you never need to check the denominator. You'll just take the numerator and you'll know whether it's negative or positive. After that, you'll have to, if it's then the p-value. So now that's where you have to know. So 30, right? T30. That means T, you have to look at the T table with degree of freedom 30. Then you go look at 2. So say it's positive 2. So you go look at 2 in the T table. And then you find its p-value. So now you should know how to look at the T table. I think this is the copyright of the T table.
เอามาจากไหน
Non-standard
อ๋อ
normal.
คิดมาจาก
Where's critical T value? Yes, so this is the T table. So you look at the DF. Yeah, degrees of freedom. So since it's T30, you have to look at degree of freedom 30.
and then
So you want to look at 2. So this is this is one tail. So you look at one tail, 30, and you try to find 2 inside.
tail 30 one tail 30
Yeah, and then you have to find 2 inside
มัน
this
ดูยังไง
table.
ว่าวันเทลหรือทูเทลอะ
on the row on the same row of 30 or not ค่ามันจะเท่ากันแต่มันต่างแค่
แต่ว่ามันจะได้
significant
ค่านี้ต่างกัน
Oh,
เราจะเอาเราอยากได้เลขนี้ใช่ป่ะ
Let me
1%
see if I get it correct.
แต่เขาไม่ได้สอนเราดูนี่นะ
ก็ไม่เห็นสอนแต่เขาบอกจะออกเน็ตแซด
he
เขาก็บอก
he
จะออก
didn't teach us
but
Yeah.
he
It's
said that
stable.
the test also in
Yeah, you need to know how to look.
have to know by half
I don't remember
so
now.
we need this right the
One table.
the number we're looking for is this like we map the degree of freedom with the
Yeah,
and then we find 2
yeah, you have to try 2. So it's somewhere between
so
here.
it's somewhere here
Yeah. But okay, so this question is so specific. You'll probably the question might be simpler then. Like maybe say like, oh, if the this is T with degree of freedom 30, and the area one tail area underneath is 10%. What is the critical value?
okay
ไม่ได้จะทำได้
10%
where
One
is
tail critical value. One tail
One
10%
tail.
at DF 30. What is the critical
okay
value?
one tail 10%
30. One tail 10%. Yeah.
Here.
There you go.
ดูยังไงอะสอนแค่ด้วย
ฮะดูยังไงวะ
ดูยังไงอะ
ใช่ก็คืออะไรวะ1 one tail
Yeah, one tail.
ตัวนี้
วันเทลดูแอนซิกนิฟิแคนเดเวลข้างบนอะ
ข้างบน
อ๋อ ก็คือดูอันนี้ใช่ป่ะ10%
ใช่ แล้วก็ degree of freedom
30. Yeah.
อ่ะแล้วถ้าเป็น2เทลดูงั้นก็
This
ต้อง
is
ดู
your
อันรูนี้ป่ะ
critical
ดู
value.
ดูโลนี้แทนถ้าเรา
this is the
10%
okay
อ๋อ
critical value okay
อ๋อ
Critical value and p value is the same
why
thing.
why we don't go
to break
Right?
oh it's not by the slide right
ใช่
Back to
go
slide.
slide by slide
โอเค
because we jump to this part
โอเคอยู่
and now we confuse
chapter 4
Okay, chapter 4.
okay the last chapter and we go to break to break
no we also have break right
ก็ตอนแรกนึกว่าตัวโตจะบอกว่าขอเบรกหน่อย
why go to each slide by slide chapter 4 talking about
น่าจะดู
about what
inference and rescaling
ใช่ใช่
okay which today he review and I think this is just for today class
Okay.
review all of
Where,
them?
where in the slide are we?
what normal distribution?
Sorry.
Okay, what is normal distribution?
If we talk about this slide as well.
You can go from the first to the last.
Okay.
Okay, let's continue where we left.
So there are different types of distribution. There's the normal, the T distribution, the F distribution, and the chi-square. Chi-square. This is chi, by the way. You write chi like the
CHI.
Yeah. I like
Chi-square.
using the symbol.
Distribution. What
Sorry.
difference between?
Square.
Normal is a bell curve.
Okay, normal is a bell curve.
T is just like normal, but it's like higher, like it's like more spread out, like this. It's like more spread out. But then if the degrees of freedom increase, it goes higher and higher, and it becomes like the normal. If your df is like approaches infinity, then T approaches normal. Sorry, I'll just write n for normal.
Normal.
Yes.
Okay.
That's why, okay, when you look at your T table,
อ๋อ
Okay, tea table please. ตลกคือจะบอกว่าญี่ปุ่นเนี่ยต้องมานั่งพูดภาษาอังกฤษแล้วก็พูดไม่ค่อยได้แล้วแบบมีแต่ต่างชาติไม่รู้ว่าใครพาต่างชาติมาให้พูดไป
อีกแล้วได้ฝึก แต่ไม่อยู่นะ
อะไรนะ
แต่ไม่อยู่ด้วย
แต่ว่าโตโต้อะคือเป็นคนไทยแต่ชอบพูดอังกฤษเลย
สุดยอด
แล้วก็
This is international class.
Yeah.
You should talk in English.
โอเค sorry em
With tuition fee of inter.
see,
Okay.
I shouldn't write on here. 1.28. I'll just write a marker. 1.28 is 0.899, right? 1.28. 0.899 is almost 10%. I'm just proving to you that t becomes like z at infinity. At infinity, it gives you 1.28 for the two-tailed. See, what is this t? Hold on, I need to know if this is one tail or two tail.
maybe it
One tail.
one tail
It's one tail.
how do you know that
Because it approaches one at towards the end, and the area under the curve
Oh,
is
okay.
always one.
so we have to focus this if it approach to one it means that one tail with
So I have to think about it this a lot.
This should be one tail, right? Okay.
Yeah, this is one tail. What this means is just shading the left. It's shading the left only continuously. This is shading the left.
Okay.
can you teach me how to use it
So okay, I'll explain first what the difference is between critical values and p-value. It's literally the same thing. Critical values
so it's the same people
versus almost it's the same thing but just different. Same but different.
สรุปมันแปลว่ามันเหมือนหรือไม่เหมือน
เดี๋ยวเขาอธิบาย
Let he explain first.
โอเค sorry em
So this is your critical value. What is the good critical value to use?
Have to be
I have to 1.6.
ให้เขาสอนเซตด้วยเพียงไม่ได้ทวนเลยว่ามันดูยังไง
I hate
เรียน
this.
ตั้งแต่ปกติแล้วจบมากี่ปี
แยกมันเกี่ยวด้วย
เขาบอกว่าให้ดูตรงเนี้ยถ้ามันทูเทลมันจะต้องหาร2ก่อนแต่นี่มัน approach to 1
จำไม่ได้แต่คุณมันไม่แยกป่ะเพราะว่ามันเป็น normal distribution
มันจะเหมือนกันใช่ไหมทั้งสองด้าน
แล้วมันหารสองอันนี้อ้าว
ของอาจารย์เขาคงแย
ใช่
ก
ใช่ผมจำอย่างนั้นว่าสุดท้ายเป็นหารสอง
แสดงว่าจริงๆก็อันนี้ก็คือพอจะใช้ก็ค่อยหาร2ถูกไหมถ้าเป็นทูเทล
ให้มันต้องดูว่าเรามองฝั่งมาบนนี่หรือว่าฝั่งนี้อะไรประมาณนั้นนะ
แต่เวลาเขียนนะมันก็จะเป็นอย่างเงี้ยพาราเรลแล้วเวลาบวกก็บวกตรงเนี้ยอาจารย์พูดว่าเอาฝั่งนี้เอาฝั่งนี้ก็แบบก็เอา50ฝั่งนี้
แต่ว่านี่ลืมแล้วว่าจำไม่ได้แล้วมันดูยังไงนะยังไม่ได้แกะเลยอะ
เฮล
อันนี้คือเซต 1.4 อันนี้ 1 2 3 4 อันนี้คืออะไรนะ
1 2 3
เราดูค่านี้นะ
4 1 2 3 4คือค่าเซตแล้วเลขในตารางคือพื้นที่ใต้กราฟ
อันนี้ไม่ใช่ค่าเซตหรอกข้างล่างอะ
อ้าว
อันนี้งงอ่ะ อันนี้คือค่าเซตปะแล้วอันนี้คืออะไรอะ
ถามกูดิ
do you know this is
คือแบบ1.11
อ๋อ ก็คือ 1.03 ใช่ไหม
จำไม่ได้แล้ว
Yeah.
When we look at this it means that z equal to 1.3 or negative 1.3
Okay. You are supposed. This is so. This is how you look at a z table. The middle is always 0 at z because z is standard normal. 0. Yeah. Okay. First, I'll teach you the how. So z is like you have 0, 1 standard deviation, 2 standard deviation, and 3 standard deviation. This is minus 1 standard deviation, minus 2 standard deviation, and minus 3. This is how standard normal is. And within this bracket, there is 68, 0.68, 68, 95, and 99 point, I think it's 99 point something. I don't remember, but yeah, this is so the area. So area always adds up to 1, right? So within here, we are like 0.68 exists, but within here, 95, and within here is almost everything. This is how standard normal works. So when you look at this, so what it's telling you is z. What is z? Z is this literal the bottom line. This is your z. This is z.
If it is minus 0.0, this way.
So you look minus 0.0. So this you look 0.
0 is here.
Yeah. So and this is minus 0.4.
it means that 0.4
Minus 0.4.
minus.
This means 0.
so
Minus
this
0.4.
is mean 5 minus 5.4
What? No.
minus 5.4
No, sorry. It's minus 0.40, 0.41, 0.42, 0.43.
ก็คือดูอันนี้
Two decimal points.
so this
ใช่
so อันนี้ 0.91
0.91, yeah. 1.0, 1.1, 1.2. That's how you
okay
look at the z table.
okay that's
Okay.
let's continue
So now how you look at the table is how do I know it's one tail? Because when I look at 0, I'll look at 0, 0, where is 0, 0, 0, 0, 50. And since it's normal, it's symmetric. So at 0, the area underneath is 50%.
Okay.
That's why I know it's one tail.
Okay.
Because Z is symmetric.
Okay.
Okay?
Okay, this is just the basic one.
Basic. So what I say is p-value and z is almost the same thing. So you look at the p-value of 1.645, then its corresponding p-value is the area. You shade the area. So this is 5%. So this is the p-value and this is the z critical value. It's the same thing. It's just like, you know, are you looking at the z critical, which is 1.645, or the area underneath what is 1.645, which is 5%. It's the same thing. You can look at it here. How can you compute this?
มันต้องมาเฉลี่ยกัน
อะไรนะของกันอะไรวะ5%อะไร
You have to look at
ก็ได้เซตแล้วก็
5%, so 95. I'll
แล้วก็
find
ดู
95
ที่
here.
ว่ามันอยู่ใน
Here.
ใน
อันไหน
ในคอลัมน์
เลเวล
ใน
ของเราไหม
ในร่องไหนใช่ไหม
ใช่
Here it's
แล้วก็ดีกรีออฟฟรีดอมว่าสมมติว่า 5%แม่งอยู่ประมาณไหน
it's not 1.645. These
95ก็95แปลว่า
ข้างในนี่คือ degree of freedom
เซตไม่ใช่
พื้นที่
เซต
พื้นที่
ไม่ใช่
พื้นที่ เปอร์เซ็นต์
อั
ข
น
อง
นี้เป็
พื้
น
น
พื้
ที่
นที่เดี๋ยว
เปอร์เซ็นต์ของพื้นที่
ใช่
like 95%
95
It's 95 because it's 5%. So because this whole thing is 1, so 1 minus 0.05 is. That's why I hate one-sided tables because you have to do the math on your brain to solve it out.
แล้วถ้าเราสตาร์ทจากอันนี้ก่อนได้ปะหรือ
เหมือนมันเป็นพื้นที่แบบอย่างเงี้ยนับพื้นที่อย่างเงี้ย
อ๋อ
สมมติได้แบบ 90%ใช่ป่ะ 90% ตรงนี้ แล้ว 10 ที่เหลือก็นี้5นี้5อย่างเงี้ย
So that's why I know S. And why is
she can remember
so the T table is the opposite because here they give you the critical values and then this is the P values.
do we need to know how we use the key
Yes, you need to know. You need to know how to use both the C and T.
I'm not sure about key
แสดงว่าถ้าเรา1.65จริงๆเราเอาบอกกันแล้วค่ะจะได้เปอร์เซ็นต์กันถูกปะ
แบบ0.55แกน
ได้เปอร์เซ็นต์อะไร
ก็คือถ้าเรา I want to know I want to know the critical probability under the curve
ไม่งั้นมันจะเป็น
was
95 แล้วก็ 2.5
equal to 1.6. We had to use the
And you
1,
look at 1.645.
4, and 5 and 6.
No. You just look at 1.64. He will not ask you to 3 decimal. I only use 3 decimal because I remember in my heart that 5% is 1.645.
So this
See, 1.64 is the 90, almost 95%.
so we round up and then it is 0.9.
You have to round. If it's not, you have to use the round.
อ๋อแสดงว่าจริงๆถ้าไม่มีค่าก็คือแค่ตัดตรงนี้ขึ้นมามันก็จะได้แล้วก็คือแค่หารที่ 1.6
This I know because I use a calculator that does the calculation for you. It's
The exam we
1.645.
have to in this number or
It depends, you know, he'll ask you might get a z-score and he'll ask you what is the p-value, or he'll give you the p-value and ask you what's the z-score, or you will have to calculate the confidence
จำ
interval,
ได้แล้วแหละว่ามันทำยังไง
which uses the z critical, remember, it's the beta hat plus or minus se z critical over se of beta hat.
Oh, I don't remember now.
What?
Can you remember or not?
I know how to use the C table, but what about the T table you
I don't
mentioned?
T-table is the other way around. You have the p-values on top, and these are your critical values in the middle.
Can you give me an example for T value? เราต้องซื้ออะไรเลี้ยง TA ไหม
So
รู้สึกใช้งานเขาหนักไหม
พี่อู้มาถามเยอะ She will pay for your meal next time because she ask a lot of questions. I already pay him at lunch.
Oh you can I'll check my
I will pay you
isn't that my
next time.
cheesecake?
we will celebrate พาเขาไปเลี้ยงอะไร
It's
เดียว
okay, it's
เลี้ยง
okay.
ไหม
You first you ask a lot of
I want to
questions.
ask like a question
Okay, ask.
how do we know when to use
He
one
also
side
ask a lot too.
One side.
one side or two
He'll
side
tell you.
He-
He'll
okay
tell you. The exam will tell you. Do a one-sided hypothesis. Two tails.
so
one
maybe
tail.
they will give two table but they will tell you that okay you use one side just
Yeah.
like this
Yeah, but the trick comes here. Since this only gives you one tail, you have to, if it's two tail, you have to like multiply it by 2 or do the math yourself.
multiply หรือ divide เนอะ
Yeah.
เปล่า
This is
มันต้อง
one tail.
หาร2ใช่ปะ
okay
FYI, this is your Z critical values. This and this is your P values in the middle. But the T table is organized opposite. This is your critical values and this is your P values.
critical and p value
The P values are on top and these are the critical values.
okay
Okay. Let
So
Okay, let give me an example and he will
อ๋อ
pay for
significant level
pay for next
we already talk about this.
ต้องมีคนเรียนของสักคนแล้วแหละเขาสอนเราขนาดเนี้ย
If you have like in the exam, oh, write a 95% CI, maybe it's T distribution with like degree of freedom 15. Okay, that's too easy. Say if we say like, oh, okay, I have like 45 observations and my number of betas is like 5. So you do the math. Oh, okay. So what is my DF?
DF,
is
okay.
You can. Oh, it's 40. Oh, let me see 40. And then you have to write the CI. So maybe you will give you the beta hat. Let's say it's just like 0.5, and the SE beta hat is like 0.5 because I'm too lazy to think of another number. So you use your CI equation is beta hat plus or minus. Sorry, this is now T critical. T crit. SE beta hat. Sorry, beta hat. Why am I using stuff? SE beta hat. So now you will write your confidence interval 0.5 plus or minus. The SE beta hat is 0.5. Then you have to look at the T stat critical. So you look at 40 at
40.
DF 40 with 95% confidence interval. Oh, so he'll say CI is always two tails. I mean, it mostly is always two tail. You just read carefully, but your CI is usually two tail.
Okay,
so you
so-
will look at two tail
two tail
at 5%.
okay and degree of freedom 40
Two tail at 5%.
degree of freedom 40.
So at 2.0.
And this is our critical value.
Yeah, T critical.
Okay.
So we
So
have
now
to,
you write 2.021.
Okay.
So now your confidence interval is 0.5 plus or minus 1.0105. So probably like 1.5105 and then you subtract 1.5. So
we divide 2 and plus
you multiply. So you get your confidence interval.
เขาสอนดูได้
ไม่ใช่แต่ว่าที่เปิดเป็นsignificant
เมื่อกี้อะ
เมมเบอร์แล้ว
CI ดู two side แล้วก็อันนี้
Two tail.
two tail and 40
Degree 40.
0.5
and they say 95
So 5%. Look at the 5%.
so look at the 5%
ที่ 5%
5%
And degree of freedom is 40. Okay.
and we take this number
95 is
Plug it in. T star.
okay
95 is a confidence level and this is a
significant level
this is confident
Yeah.
level and this is significant level
ขอถ่ายรูปหน่อยครับ ได้ไหม
เดี๋ยวพี่จะขออันนี้ไปขอเราไป
And
ที่
then
เรากัน
so
นะ
you will have your confidence interval, which is probably like from 0.5 to 1.5. And then he'll ask you to do, maybe you do the hypothesis test like, wage is like blah blah, maybe 2. It's outside the interval. Reject.
no
Inside the interval, accept.
Okay.
Fail to reject.
good
thank you teacher
Okay we ran out of time we just have 20 minutes
but I will together with you
You can keep this book if you want. I will leave my book.
I want this but I cannot
จะหมดแล้ว
I cannot read it
โอเค พี่อุ้ม he give this to your book
อ้าว
he already tried just you ask a lot of questions
no he the one who
I think we should finish at 6 p.m. because he is already tried
Inference. Hypothesis testing. Do I need to cover hypothesis?
yeah we have to cover this part as well
I don't understand it
okay now we stop asking questions ก่อน
you the one who asking first
you asking a lot of
No, no.
questions
อัดวิดีโอคนเถียงกันเนอะ
you asking a
พี่
lot
ภาพ
of
อย่าอัดไปนะ
โอเค
ต้องอัด
slow down
เขาถามก่อน
now we don't ask you question you just go by slide by slide
you want to go at midnight
No.
you too hard
Okay, you just need to know how to read the output.
yes
So here, this is how you read the output.
yes
Do you know how to read the output?
no I don't know I skip this
he
part
don't know everything because he play football and
no let he talk let he talk
ก็คือ
let he talk ภูมิ shut up
don't interrupt
So this is how you read your output. See wage. So this is your beta. So beta for the education, beta for
beta 1 beta 2 beta 3 right
that is beta 0. Beta 0 is at the end. Constant is beta 0. CONST. It's constant.
to take note okay
he cannot see
what is slide what is this slide
ไม่เป็นไรไม่ต้องให้นี่มันออก
นี่เหมือนกันจดอยู่
แล้วก็ดูว่า
ตัวก็ดูอะไรดูอันนี้เขาเป็นแขกเขาจะติวให้ต่ออ่ะ
okay let's
let's move on
let's
not go back
Okay. You know how to read this, right?
no
Now how to read the starter output.
no I can teach you this is a beta for education beta for
I know
And this is the beta. The lowest is the beta for constant. Constant means beta 0.
beta 0
And this is your standard errors, SE, so of each thing. And this is your t-stat. This t-stat is calculated using 0. Like, so it's testing whether if your beta is equal to 0 or not. So when you look at this, it's all significant. That means you reject that it equal to 0. So it means something. That means it's, that's how you look at it. That's it. That's pretty much it.
so if when p value greater than p stat
P-value and t-stat is the same thing. It's the same thing.
but what is about why we have
What this means is this t stat, right? And then this is p value. It's the same thing.
he already let his voice
ทำไมมันติดกับติดกับ
then you ask พี่ปาล์มเดี๋ยวพี่ปาล์ม will
You
explain to
understand, right? T
Yeah.
value and p is the same thing. This
Yeah.
is t value and p is the shaded of the t.
yeah
อ่ะแล้วทำไมมันอันนี้มันหมายถึงอะไรนะถ้ามากกว่า absolute t อ่ะ
is it the same thing
Absolute t means two. Absolute t. What is the meaning of absolute t? It means plus t minus t. It
Oh,
means
okay,
two
okay.
tails. So you have minus t here, plus t here, and then it's shade on both sides. So it means two tails. That's why I
okay
show you
it's the same thing
absolute t.
now
โอเค
Okay, and this is just your p value.
ก็คืออันนี้แปลว่าจริงๆ t value two tail ป่ะ
absolute
Absolute, so it's
Plus
plus and
minus.
minus. So it's two tails.
don't be mad
Okay.
at her don't be mad at her. I'm no your uncle now
Okay.
โอเค โอเค
So I think it's yeah. So this is how you read the table.
โอเค
So this tell you if significant or not.
what other important part about this
You
table
need to know how. So you see a number of observations.
is 526
Yeah, and then you can count the number of betas just by counting how many are here. So education, experience, and constant. So 3 betas.
T beta
You can
here
count the number of
Slide
betas
leh.
by this.
T beta here
เท่าไหร่ตัวต้น
21.
slide 21 T beta here okay good and
เห็น
listening
เห็น t value is the same as
It's the same, but it's the
two sides or two sides
no, it's same. Like it's like no. How do I say? It's not the same, but it's the same.
yeah it is the same
You look at it another way. You look at the area, or you look at the number that marks the area.
okay
I don't know how to explain it to. You
เจ้าสูตรจำไหม
สี่ซีโร่ซีโร่วันซีโร่
จริงจริงจริง
zero means your p value is 0. Means it's good.
it's good
P value less than significance level means you reject.
why when we reject thing because we have to this
Why it's a good thing? Because when you what are you testing? You are testing that this is equal to 0. So you if it's equal to 0 and you fail to reject, that means your coefficient is 0. So it means your regression is meaningless, worthless. So you want to reject the fact that it's 0.
เฮ้ยเอกฟลิป
How this work is that remember the t-stat equation beta hat minus beta over SE beta hat? What theta does is theta uses 0 here. So it's beta hat minus 0 over SE beta hat. What this means is your HO, your hypothesis is beta hat equals to 0. Which means beta hat is no effect, meaningless. So you are rejecting means good because it's worthless. If your beta hat equals 0, it means your regression is useless. So your HA is beta hat does not equal to 0.
โอเค
So if you must only rejecting means that means your beta hat it has some meaning. It's not 0.
โอเค
That's why it's a good thing.
what this is what
No, it is
a way
H1.
alternative
no
hypothesis alternative
อ๋อ head one
H1
is a way to reject no hypothesis a way
you ask a lot of question
sorry but
it's too much
It depends on how you set up your alternative hypothesis, you know. Do you want to reject or do you don't want to reject? It just depends on
she
how you
is
set
very
it up.
eager to learn everything every important thing everything is
You
important
should
for
read
her
you should read the textbook.
yeah you should read the textbook not ask him okay you
okay continue
okay we have 10 minutes
Okay, what else? Estimating generate. This is multicollinearity. This is just all status stuff. So I'll just go combination of.
is he test about statista
No, you're not in front of a computer, so you won't need to know how to write stata code.
อ๋อ
You know, give you the output, and then you have to do this thingy for him.
so probably logistic
Yeah, you just need to know how to read the output, like I showed you. One thing that I want to tell you is to know how to do this thing. If I make it.
พี่ปาทำอะไรอ่ะไม่
Okay, so I ran out of paper, so this is the end.
This is the end.
If you ran out, you can write at my sheet.
This is the end.
Can we extend the time to
No, no, no,
I-
no extend time.
we should respect time
I have
No, we have limitation.
but my knowledge is
You ask him in line. If he
I
answer,
mostly-
if he answer you.
So what you need to know is, remember I should talk to you about transformation and calculating. Okay, I need a break. I want to go to the toilet. I'll be back. And I also want to drink water too.
okay
It's very important.
what?
And AND. It's my short form for and.
And
And AND. There you go. So transformation and the short term or the joint betas.
you want to อ๋ออันนี้มันปิดแล้วนะจะได้ซื้อเลี้ยงเขาจะได้หมดหนี้กันนะ
Why you need to know this? Because when you do hypothesis, say you want to test like beta 2 plus beta 3 equal to 0. Maybe. So your test stat is beta hat 2 plus. Bye bye. 3 minus beta 2 plus beta 3. Sorry, is it correct? Am I doing it correct?
I don't know. I
There you
will.
go. Now it's correct.
Don't ask him so much
Beta, no, I asked him. Plus beta 3. Something like this, right? So this is your T. But what you don't know this. You don't know this. So that's why you have to either transform or do the calculation when you have. This is you need it to do your T stat.
โอเค
No more paper.
เอาโอเค
Time for end.
Okay,
Time to
I
end
have.
now.
Okay. Let's go on.
Okay.
What else?
minute left
So there are three ways to calculate like maybe you want your because you need your SE like maybe under beta minus beta 3 there are three ways to calculate a joint SE for beta because you want it for your T stat, right? Because your T stat is like probably beta 2 minus beta 3 minus beta 2 minus beta 3 sorry over SE beta 2 minus beta 3, right? So you need the T-stat to do your hypothesis testing, so you need to do this, and there are three ways to do this. One, transform. So say your model is y equals to beta 0 plus beta 1 x1 plus beta 2 x2 plus beta 3 x3. So now you will start your transformation. So you want to get beta 2 minus beta 3. So how you do that? You do that beta 0 plus beta 1 x1 plus beta 2 x2 minus beta 3 x2 plus beta 3 x3 plus beta 3 x2. Did you get what I do? No?
No, I'm confused now.
He asked him a lot
No.
He only 4 minutes left
No,
That's-
let's
It's okay.
extend.
It's okay. I can stay until like 6:15 if you need.
Yes.
I do it myself.
can
Okay.
7 p.m.
No, 6:30.
Okay, he extend.
So, okay, what I did is this model, you see, but you want this. You want to have minus beta 3. So what I did is I added minus beta 3 x2 and here I added plus beta 3 x2.
So 0.
So 0, yeah. But then you distribute it in. So So it's become beta 0 plus beta 1 x1. This will become, see, this will become beta 2 minus beta 3 x2. And then you will have plus
ถ้ากลุ่มเราคะแนนมีหมดก็น่าจะมาจาก
sorry, beta 3. So you will have beta 3.
เขาด้วยนะ
This is plus, so you have x2 plus x3. So this is your transform
โอ
model.
เค thank you
So that means when you have your stata, when you run this on stata, it will give you the it will give you the SE of this immediately. Your x2 is this.
and after that
So that means you get your t-stat. This is one way to do this problem.
so and after that we already have one
You
at least.
then you just do the stata output. Yeah. Because then it will be your x2 will be the beta 2 minus beta 3. So you can just look at the t-stat directly.
In the exam he already give
I don't know, maybe he will do it like this, maybe he will give you this, you go backward, or this and go there, or but if you know how to transform, you are good. Then because x2 is this thing. Now that you transform, x2 is now this thing.
What happened
What? No.
จบแล้ว The end
I'm just trying to get rid of it. So you understand, right?
Okay I understand
Is to solve this, you can transform.
Okay I have
and
to
when
transform
Remember, your x2 will become beta 2 minus beta 3. See? So the t-stat if you run this regression, then the t-stat is literally equivalent now. If you run it like this.
and we have to look again in the table to find the value of beta
Yeah. This is one way you can do the joint, if you have a joint combination of tests.
Okay joint combination
Like here, like beta 2 minus beta 3 combination. And that's the first way you can do it. The
Oh
sec-
just the first way
Yeah, you need to know all three ways.
Transform.
Transform. Second way is you do it by hand. By hand.
เรียนรู้เรื่องไหม
So maybe there will be a variance covariance matrix over MATRIX. So variance covariance matrix. So maybe this is beta 1, beta 1, beta 2, beta 2, beta n, beta n. So this is the variance of beta 1. This is the covariance between beta 1, beta 2. It's the same thing. So this is variance between beta 1, beta 2. And this is the variance of beta 2. You get it? No? I mean, this is the variance covariance matrix.
Okay.
It's an output.
Yeah.
So you have, beta 1, covariance of beta 1 and beta 1
Oh,
is
it's the
variance.
covariance.
Covariance of beta 1 and beta 2 is covariance beta 1. Covariance of beta 2 and beta 1 is covariance of beta 2.
Okay
Covariance beta 2 beta 2 is variance of beta 2.
yes understand
Got it.
Okay.
Got it, yeah.
So now how you do that SE calculation, I don't remember by heart, so I have to I just copy it down for you. SE of beta hat plus beta hat is
พวก
equals
หยิบขนม
to
มาให้หน่อยจะให้เขาหมดเลยเขาไม่
square
กินแหละ
root
ไม่ใช่ของเราปะมี
variance.
มีอันนั้นแล้วก็ในถุงไม่ใช่ถุงนั้นดิถุงที่มีเค้กอ่ะคนกบอะไรอ่ะอ๋อนั่นแหละDo you like Would you like
No, it's okay. It's
I
okay.
don't want to eat that
I don't want to either.
Why you give what you don't want to him
Everything you said you will be reject
รอบหน้าเขาไม่มานั่งด้วยแล้วมั้ง
Over to Korean.
So this is the second way you do it.
โอเค
So now that you have your SE beta hat, you just plug that into here, and then this is you already have it, and this you
Okay
now you get it. So
Yeah,
this is
I get
the
it.
for equation you use. So
Then go how to plug in again.
you just plug this in to the
Oh, okay.
yeah. That's another way to do it. the last way is the F, the way, the F test. F of n, oh sorry, 1 comma n is distributed as t square n. Clear?
Everyone stun now.
So an F test
It test
with one restriction, a joint restriction, and n degrees of freedom for observe is the same as a t with n degrees squared. So when he gives you, like maybe, remember he did the F thing and then you square root it to get the T, that's where this comes from, where you can do it because of this, there's this relation. But you must make sure this is 1. If this is 3, wrong, you cannot do it.
why if it's T you can do it.
Because the distribution is not the same. Because this means that this distribution is the same as this distribution. That's what it means. So how you do? Yeah, that's pretty much it. And then remember, you test whether if positive or negative, and you do the T star after that. Yeah, those are the 3 ways you can get the SE beta. Yeah, 2 like joint betas. The SE of any joint beta.
Okay.
1 transform, 2 by hand, like the Kobayashi matrix, or 3 is you use the F1N and you transform it into T.
So what is the easiest way?
Depends on the question. If he will ask you, I mean, if you're given the F, you have to use this method. But if he give you the Kobayashi matrix, you use this method. If he give you,
like this.
if you give you a transform model, you have to use the transformation way. So you need to know all 3 ways to do this.
Remember the input and what he give you.
Yeah. And I think that's pretty much.
Okay. He ran out of time now.
Let me just see what else here in lecture 4.
I don't understand anything.
Oh, okay. Then I cannot help you.
I am not sure about myself.
Hypothesis stands for linear combination.
I teach you a new.
Okay.
Maybe
That,
after midterm,
why did he teach
he
you chi
will
square?
pay for you.
I already pay for him.
He did treat me for lunch. Thank you though.
จริงเหรอ วันไหนอะ
ก็บอกวันนี้
Rescale that you had.
โอเค
Rescale?
No.
Oh. Confidence. Oh, CI. I did talk about CI. Hypothesis test. That's it. That's all you need to know.
I want you to teach me for introduce the table, the value the table.
Coefficient, standard error.
It's something like that.
That's it. I mean, what do you want to know? The table is the easiest.
Spend the night. Tonight review everything.
That's
with
it.
this framework.
Okay.
Okay, that's everything.
Thank you very much.
Thank you so
I
much.
really appreciate.
I don't